So we are looking at the product rule here, and we're going to start off with this wonderful little picture of Disney World, because I will tell you that when I was a little kid, my family went to Disney World and we rode on this thing called the monorail, and it was a lot of fun. But the most fun part was in the very front. In the very front, they couldn't really seat a lot of people. So we would get into fights, my brother, my sister, and I, of course, who gets to sit in the front, until my parents came up with what I guess is a pretty standard rule. They decided everybody gets a turn. And what does that have to do with the product rule? Well, actually kind of a lot. So here is the product rule. Whoops, and there it is. So if we start with a product, some function A is equal to f times g. If we try to get the derivative of that, it turns out, and I will prove this in a separate video, it turns out that the derivative of A, which was a product, is equal to the derivative of f, here it is f prime, times g, but not the derivative, just original g, and then plus a second term, which is the original f and the derivative of g. And so what you can kind of get a sense of here is that, like little siblings fighting to be in front of the monorail, everybody gets a turn to be the derivative. First f gets to be the derivative, g watches, then g gets to be the derivative, and f watches. In a little bit of a simpler notation without all of the of x's, the derivative with respect to x of f times g is f prime g plus f g prime. Again, everybody gets to be the derivative. The nice thing about thinking of it in these terms is that when you deal with a larger product, in this case 3 factors, again the rule holds completely and everybody gets to be the derivative. First f is the derivative, g and h watch. Then g is the derivative while f and h watch, and then h gets to be the derivative where f and g watch. So we're going to go ahead and take a look at an example here. This is the proof that I'm going to put up in a separate video. Let's take a look at the derivative of this product, 2x minus 3, 3x plus 1. And there are actually, in this case, 2 ways to solve this problem. One is we could FOIL it out and then take the derivative. If we were to do the FOIL process, we're going to get 6x squared. We have a negative 9 and a positive 2, so minus 7x, and then minus 3. And the derivative of this will be, from our previous rule, 12x minus 7, which is not so bad to do. But if we try to use the product rule on this, we get the following. We get the derivative of the first, that's 2, times 3x plus 1 just kind of hangs around, plus 2x plus, or 2x minus 3 stays there, and then the derivative of the second term, 3. If we distribute through, we get 6x plus 2, lost me on that, plus 6x minus 9, and that's 12x minus 7, same derivative that we had before. And I'm back. Now let's take a look at another example. I'll put it down here a little bit lower on the page. Because you can't always get away with just multiplying something out. What if we had the derivative of, say, x to the 4th times the sine of x? Well, in this case, there's no expanding that I can do, but the only way to take the derivative is with product rule. And it basically says, think of this as an f and a g. So we have the derivative of f, that's 4x cubed by power rule, times the sine x that just hangs around, plus x to the 4th that sits around, and now g gets its turn, the derivative of sine is cosine. And we could stop here. This is done. Or if we really felt like it, I suppose we could factor out the x cubed, which could be something that would be necessary, leaving us with a 4 sine x plus x cosine x. So what else can we do with the product rule? Well, we can do some other interesting things. For example, we could take a look at the derivative of something along these lines, x plus 1 to the 4th power. Now, I could go through and attempt to expand my x plus 1 to the 4th, and there are shortcuts for that. But we're going to look at this in a different way. What if we looked at x plus 1 to the fourth as an extended product? It's x plus 1 4 times. And then we use the product rule basically on 4 factors. The interesting thing here is that each factor is exactly the same. So here's what happens. We would get the derivative of the first part, and that's going to just be 1, times the other 3 parts just hanging around. Well, that's x plus 1, well, cubed, isn't it? Because there's 3 of them. Then we go to the next term. Now we're going to take the derivative of the second one. That derivative is 1. And that leaves us with the other 3. Well, it's the same thing again, x plus 1, and there's 3 of those. And when I do it for the third one, I'm going to get another one of exactly the same term. And then when I go and look at the last one, I get one more of those. Derivative of this is 1. The other 3 factors hang around. And what we actually see is we have the same exact term 4 times. So we get 4 x plus 1 to the third as the derivative of our original problem. Now you might look at the original problem and think, wait a second, something to the fourth gets us 4 something cubed. That's kind of like a power rule. And is that what's going on down here? Well, I don't know, but it is something we're going to be looking at very, very soon. So I'm going to leave it at that. So there's a little bit of the product rule. I'll post a separate video looking at the proof of that if you want to take a look. But for now, that's it.